So the two different ways to solve it with these problems is, first you can turn this into an exponential equation. The base to the answer power is equal to the inside. Real easy, 9 would equal x. Same with this one. You could say, well, first you'd have to get the 2 out of there and make it log base 7 of negative 2x is equal to 2. Then you could do the same thing, that the base to the answer power has to equal the inside, and then you could solve that 49 divided by negative 2 would equal x. Technically, what you're doing in that is, to get rid of the base, you are using the base as an exponent. So when you rewrite that, you'd get x equals 3 squared. Hey, that's the exact same thing you did here. If we took this as 7 as the base on both sides, negative 2x equals 7 squared. Again, the exact same thing you had. So either way, it solved it the exact same way. Now here's where the log equations come into play, because with this here, you can only do that if you have one logarithm on this side, not two logarithms on the left. So we need to find a way to combine this into one logarithm. Well, the first log property that we had, if we go back, said that if you're adding logarithms, they can be condensed as a multiplication. So I can multiply the x and the 2 for your inside. So then you could say, this is log base 10, so I'm raising both sides with 10 as the base. Gives you 2x equals 10 to the first power, and then solve by dividing by 2. 10 divided by 2 is 5, and there's your answer. Here's one with subtraction, so that means to condense the log. Log base 6, subtraction means you have division on the inside. Equals log base 6 of 29. And technically, you should go and raise each side with 6 as your base, but if you have a log on both sides anyway, log of junk equals log of junk. So x plus 1 over x equals 29. That's a basic cross-multiply equation. 29x equals x plus 1. You should end up getting x equals 1 over 28 as your answer. That's calc. Next kind here. You have a number out in front with your ln's, or any log. Bring that number in as an exponent. This side becomes ln of x squared as a result. So ln of x squared equals ln of x plus 2. ln on both sides, they can cancel out. X squared equals x plus 2. Now it's a quadratic equation. So x squared minus x minus 2 equals 0. X minus 2 times x plus 1 when you factor that. So x equaling 2 and negative 1. Now here's the issue. What we should have been doing on all these, remember, is to check, because you can't take a negative on the inside. Well, 1 over 28, when you plug each of those in, is fine. You still got a positive number. Plugging 5 in, you still have a positive number. That's good. This one here, though, go back to your original problem. If you plug in 2 into both, they would work. But if you plug negative 1 in, well, that right side logarithmic equation works, but this one would not, because you're taking log of negative 1. Can't do it. This right here is an extraneous solution, so your only answer is x equaling 2 as a result. So make sure you pay attention to those. All right, so here's 3 for you to try. I would hit pause and see if you can set up your answer. Let's play when you're ready. So let's see how you did. Let's reveal the answers first. It's an awkward answer for that second one there. Understandable. But let's see how it goes. First one, divide the 2 over first. Get rid of the log by raising each side to 9. So 9 to the 1/2 power means the square root of 9. So that's 3. Subtract the 2 and divide by 5. And you get x equals 1/5. For the second one, you need to condense it first. 2 over 3x plus 2. Raise each side to be the e power. That gets rid of your logarithm. And then really from there what you're doing is you're going to cross multiply. So if you think of that as e over 1, kind of like we did in the last slide, then you can cross multiply and you can solve your equation there. This last one, a little bit tricky. The right-hand side, you can use that last log property and call this log base 3 of 16. That way you have log base 3 on both sides. And then you can bring the 4 into the exponent using the log rules. That way you have log on both sides. They can cancel out. That's why you have x squared equals 14, or x to the fourth, is 16, and x equals 2 then as your answer.